Good morning, everyone.
Morning.
How's everything? I would really appreciate that time that you want attend FMRI IT chapters webinars. I will appreciate if you don't have a question to mute your microphone, or I will ask the host of this event to mute everybody else microphone, so we will not have the echo. Uh, this is I hope everything is fine. Coronavirus pandemic have changed a lot of the lecture series for the university, and especially here at the Florida Atlantic University. My name is Evangelos Kaiser, and faculty at the Florida Atlantic University. I'm going to be the moderator today with Ms. Aline Machado. This webinar it's up to the presenter, Ms. Taraneh Ardalan, how she's going to handle the questions, but I would recommend, if you have any question during the presentations, to send the question to me or to Aline Machado by chat, so we can we have the question and answer section at the end, or you can ask directly the presenter at the end of this presentation. I think, Taraneh, we are ready to go, and I would like to thank Mr. Taraneh Ardalan that accepted our invitation for the first webinar session for the summer 2020. Mr. Taraneh Ardalan completed her graduate studies at the Florida Atlantic University successfully. She has been contributed in many projects sponsored by various agencies like Florida Department of Transportation, City of Dania Beach, USDOT, and was very active with IT student chapter at the FAU. She's the founder of the Women Transportation Society at the FAU, and we are really glad that we have a new session, WTS session at the Florida University. She has presented her work in various conferences in the state and the national, in the nation, and also she's going to pursue her PhD degree at the University of Pittsburgh under Dr. Stevanovic's supervision. We are really glad that we had Taraneh in our group, and Taraneh, the floor is yours.
Thank you so much, Dr. Kaiser. Good morning, everyone. I'm very pleased for this invitation to present one of the projects that I worked during my master's. I would like to thank the Flexibility Research Institute, a Tier 1 University Transportation Center, which gives me the opportunity to work on different projects and learn many things. This project is sponsored by the Florida Department of Transportation, and it was a great collaboration teamwork between Florida Atlantic University and Florida International University with Dr. Muhammad Hadi and his research team. Also, I would like to express my appreciation to Ms. Gabriel Matthews, the project manager, and the public transit team, David Sherman, Chris, Kyle, Anna, and so on. Moreover, this work could not have been completed successfully without the helps and guidance of Ms. Atem Long, the freight coordinator of FDUT District 4. If you would like to see more information, the final report will be available on FSP Research Center website and also FMRI website. So here is a glance of today's presentation. I will start with an introduction, including some basic information about transit signal priority and freight signal priority. Then I will continue with the research background and objectives. Afterward, I'm going to explain the research methodology. Eventually, I'm going through the results, including the proposed guidelines. the validation of the process, and the evaluation of the results. Last but not least, I will finish the presentation with conclusions and some recommendations for the future studies. The demand for freight transportation is increasing all around the world and especially in urban areas. As you can see in these figures from Bureau of Transportation Statistics, the number of trucks and buses are increasing steadily from 2000 and it will continue. There is an expectation for great increase and growth in road transportation from 60% in 2016 to 78% in 2045. It is predicted that the use of trucks will rise around 30% between 2016 and 2045. In addition, due to the urbanization, the number of passenger cars and also public transportation will grow in cities as well. At the end of the day, all these rises will result in more congested cities with the heavy traffic. Congestion along the national highway system is already a significant issue, which is expected is growing rapidly in the next decades. These two maps are presenting the peak period congestion on high volume truck portions around the national highway system. Assuming that there will be no change in network capacity, then the increase in truck and passenger vehicle traffic is predicted to expand from 2012 to 2045, and you can see how it goes, especially in Florida. Traffic congestion in cities will result in more queuing, more number of stops, more travel time, and more delays, in addition to less mobility, less safety, less reliability, and efficiency. One solution to solve this is using traffic controllers, such as traffic signals in signalized intersections. But the disruption from the traffic signals would make some inefficiencies. One of the solutions to tackle this is the use of intelligent transportation system technologies such as transit signal priority and freight signal priority that I'm going to explain later in this presentation. Besides that, on multimodal corridors, trucks are deteriorating the system by their slow dynamics and also slower acceleration deceleration time. We'll experience the situation of being stuck behind a truck, and only one stop of a truck can cause a backward shock wave. This can result in the 2/3 of energy loss at intersections. Trucks can also increase the congestion, decrease the mobility of other vehicles on the road, and affecting the environment by producing emissions and consuming fuel. Therefore, if we can reduce the number of stops for trucks, the whole network can get the benefit out of this. In this slide, I will refer to similarities of TSP and FSP and how we can benefit from them. In TSP, the technology is using to detect the approaching buses and then asking from the signal to provide priority to them. And in FSP, the same process is applying to trucks. Buses usually spend around 15% of their trip time behind the signals. Trucks are almost wasting $28 billion annually in congestion in terms of time and fuel. By reducing and decreasing the travel time for transit vehicles, not only some fuel will be saved, but also because of its reliability, more people will be encouraged to use the public transit. Moreover, by giving green lights to trucks, besides the reduction in fuel consumption, the maintenance cost for the pavement will be decreased as well. Here, I'm going to mention some of the papers and previous research in this area. In 1999, by the use of microsimulation, Garrow provided some recommendation and guidelines for TSP for off-peak and peak hour. And the evaluation of their work was based on transit route, transit usage, and time of the day. Chada in 2002 conducted a study to develop a guideline for TSP and how it can be beneficial. They initiated this work with a pre-implementation checklist, and they provided some recommendation based on the points from the checklist above. In 2005, the TSP handbook was developed by Smith et al. They revealed the need for benefit and feasibility evaluation in addition to budget assessment and investment analysis. Moreover, they provided concept of operation, a detailed guideline for planning, designing, implementation, and maintenance. In 2014, Hu et al. Proposed another methodology considering delay per person by the use of connected vehicles. And their methodology is shown in this figure. In 2018, Dr. Kaiser with his research team at that time conducted a study for identifying the corridors for deploying signal priorities and queue jumps based on some factors like bus speed, bus frequency, bus stop location, slack time, and volume over capacity. In terms of freight signal priority, there isn't many literature available, especially regarding a guideline. So I'm going to mention some of the studies related to FSP in general. Sunkari et al. In 2001 conducted a study for minimizing truck stops in rural areas by the use of loop detectors for detecting trucks and then minimizing the number of stops, delays, and pavement wear. In 2009, with video sensors in order to provide safe and efficient movement for freight vehicles. Perry et al. In 2014, by the use of connected vehicle technology, developed an algorithm for truck signal priority in order to reduce energy and emissions. Zhou et al. In 2016 proposed the positive effects of truck signal priority on the movement of freight by green extension. Last year, for the same project that I'm presenting, Manta evaluated the implementation of FSP and TSP in urban corridors by considering travel time and delay in a real-world macrosimulation model. And in the same year, Washington State DOT prepared the factors for considering the FSP eligible corridors based on their study in a corridor that is close to ports, airports, industrial areas, and distribution centers. FSP can be implemented. In addition, in uphills that trucks need to accelerate after red light or downhills when trucks need to brake harder to a stop for a red light, it's recommended for FSP implementation. In addition, they identified some benefits for implementing FSP on a corridor, such as improving safety, reducing congestion, emissions, and these are some of the impacts that FSP can provide. Overall, from the literature, we got to this point that TSP or FSP might not be effective for all traffic conditions, signal controls, and geometric locations. So it is recommended to do a thorough research before taking any action. Above that, the literature provided only some criteria or guidelines only on either FSP or TSP, not both of them. So we came up to this idea of implementing FSP and TSP simultaneously due to the heavy mixed traffic in urban areas. And for that, traffic agencies need some guidelines. Therefore, the objectives of this research is to first develop some guidelines to identify the feasible corridors for implementing of FSP and TSP, and second, to evaluate the effectiveness of them in improving the performance of freight and transit movements. In this slide, you'll see the research methodology. First, after a couple of meetings, we determined the case study location. And after that, it was time for data collection, creating and developing the base model and calibrating it, then deciding about different scenarios, running them, and also getting the results. Then, by analyzing the results and gap analysis of the literature, we figured out that the fundamental factors for developing the guidelines after we have the implementation of method, including several steps such as considering a signal intersection, developing decision trees, developing the FSP TSP checklist, and then we developed the guidelines, and after that was the time to validate the guidelines. Again, we had some scenarios for the validation and then evaluation the results intersection by intersection. I'm going to explain in detail of the mentioned steps by starting with the location of the case study. The methodology and evaluation was applied on Sunrise Boulevard in Broward County. This case study is 4.2 miles corridor with 20 signalized intersections. It has 5 bus routes, and because of its strategic location near port of Everglades and Fort Lauderdale International Airport, it has a high truck volume. In terms of data collection, we selected the morning peak hour. So we collected the traffic counts, vehicle classification, truck characteristics, and also transit data. Then the modifications on the existing model was applied in VSIM 11, and then the calibration was done successfully by the use of Bluetooth travel time data. We implemented the detection system as shown in the figure, and also we adjusted the signal timings. Here in this slide, you can see the developed model in VSIM. After several meetings with the stakeholders, 7 scenarios were selected for evaluating the performance of TSP and FSP on Sunrise Boulevard, including only freight signal priority, conditional FSP type 1 by excluding type 5 of trucks, which we didn't want to give priority due to the highest amount of them, and less importance because they are not actually mostly not the heavy vehicles. Then it was conditional FSP type 2, which is excluding trucks type 5, 6, and 7, basically providing priority only to the combination trucks. Other scenarios are only transit signal priority, both FSP and TSP, and other configurations of conditional FSP with TSP. We run the simulations for 5 times, each of them 1 hour and 15 minutes, with 15 minutes warm-up and 1 hour simulation. By evaluating all the results from different scenarios that we provided, I'm just going to mention as a really conclude slide about the results here. We compared them with the results of base scenario, and we got to this point that the consideration of only freight vehicles or only transit vehicles, the performance of FSP and TSP is the most efficient, and this outcome also shows itself in comparison of all vehicles. Afterward, for starting the process of development of guidelines, we discovered from the literature that some factors are more important, such as volume over capacity ratio, slack time, bus occupancy, bus frequency, trucks weight, bus stop location, and so on. But we realized that for comparing the value and importance of different vehicles, there should be a scale. According to Hadi's study in 2019, there can be different dollar values for the travel time of passenger vehicles and trucks, in addition to the occupancy of passenger cars and transit vehicles. In this mathematical model, we consider travel time for assessing the values. You can see in the equation that C is the total cost for a specific signal configuration, D is the delay for the specific vehicle type, and beta and O are value of travel time and occupancy respectively, and they can be estimated according to this table. Then for making the decision, B can be calculated by subtracting the total cost of the base model, which doesn't have any priority, from the total cost of each signal configuration. So we use this mathematical model in order to see how it goes with our guidelines. In order to develop the guidelines, we selected one specific intersection from the case study, actually randomly, and we developed various configurations to apply with different volume over capacities and freight percentage and transit frequency per hour, as you can see in this table. We developed the guidelines based on considering the major road and minor road, in addition to various configurations with traffic volumes, freight percentage, and transit frequency. In addition to those factors, we created our FSP TSP checklist, and if a corridor, to see if a corridor is feasible for applying FSP and or TSP. Here in this slide, you'll see the final guidelines, and the decision trees resulted from several runs and configurations I mentioned before. The first factor is the existence of enough time for providing priority. Therefore, the flag time should be more than 5 seconds at the intersection. If not, so there cannot be any priority. There cannot be any priority strategy to be implemented. And then if yes, then the traffic agency should decide if they want to provide a priority on the major road or minor road or even both. And then to decide between only TSP, FSP, or both FSP and TSP. And then for each of them, there is a decision tree, so they can use and follow the procedure for the decision trees. The developed guidelines here are based on the simulation results. The simulation model considers different vehicle classes, their calibration process, acceleration and deceleration of the freight vehicles. For the validation of the guidelines, again, we worked on the intersections in Sunrise Boulevard. So we checked each intersection separately by itself. The first factor, the first step was to check about the slack time. And for all of the intersections in our case study, it was fulfilled with 5 seconds, so we could move further. The second step is was the determination of the application of priority on the major road or the minor road. We decided to apply on the major road. Then the third step was to check the FSP TSP checklist. So according to this checklist, 4 out of 5 factors from FSP was satisfied and 3 out of 3. So we decided to implement both FSP and TSP on the case study. In the fourth step, we implemented all 3 strategies on each intersection, in addition to no priority scenario for making the comparison. The results in terms of travel time cost is provided in this table. As you can see, it shows that FSP only has the highest benefit with 6.63%. And after that, it was the implementation of both FSP and TSP with almost 6%. Therefore, it is more reasonable to provide priority to 2 modes of transportation rather than only one, and get the almost same benefit for the system. For evaluating the results, we collected the average travel time for all intersections after 5 runs for each of the scenarios. And it shows that as you can see here is the travel time analysis for the eastbound. So as you can see, FSP scenario has the highest decrease of travel time in comparison to base model, which belongs to HGVs with 22%. And same applied in TSP scenario with a 13% decrease in the travel time of buses. But the best happens in the application of FSP and TSP with 12% lower travel time in passenger cars, 17% for buses, and 18% for HGVs. The same trend also happened in the westbound with 6% improved in passenger cars, 32% in buses, and 16% in HGVs. Again, here in this figure, you'll see the average total travel time for various scenarios with the same outcomes. In regard to the average delay for the major road, as it was expected, considering all vehicles and freight vehicles and transit vehicles separately, for eastbound and westbound, it's observed that the combination of FSP and TSP in most of the scenarios owns the lowest average delay in all the scenarios. Then we decided to evaluate the minor roads as well. But as you can remember, we only gave the priority on the major roads. So it was expected that in most of the intersections, the application of FSP and TSP, the yellow dots, has the highest travel time. TSP scenario, the orange dots, has the lowest travel time due to the lower number of transit vehicles rather than cars and trucks. By comparing the delays in the minor road street with a box plot, it illustrates that the base model has less variation in delays, and yellow box, which is a combination of FSP and TSP, has the greater variation. The reason that the box plots are different in size is because of the number of vehicles that they serve. For instance, the median in TSP box, the TSP box plot, which is the orange one, is less than of the FSP, the gray one. It's because of the volumes of the difference between the volumes of trucks and buses. For concluding the presentation, here are some points that I would like to share. The application of FSP and TSP has a positive impact on the movements of freight and transit vehicles. The highest mobility is provided by the implementation of both FSP and TSP. To consider an intersection for signal priority, the first factor is the slack time of more than 5 seconds. In condition of priority on major road, minor road will face more delay, so it's more beneficial if priority could be applied on both directions. In this study, we developed separate guidelines for different occasions and for considering both major road and minor road. These guidelines can be utilized in projects that freight movement is of great importance. And finally, this study has found that FSP and or TSP may not be beneficial for all conditions, and the importance of simulation modeling and thorough research should not be neglected. Some suggestions for continuing this work would be to identify the aspects and impacts of freight movements on the network, to develop scenarios and give some weights on FSP and TSP, providing priority based on different commodities of freight vehicles, implementing FSP and TSP on a wider network, and following the proposed guidelines to see how it works on different occasions, and the deployment of FSP and TSP based on guidelines which can consist of feasibility assessment, evaluation of their implementation, and so on. Thank you so much for your attention, and if you have any questions or suggestions, I would be really happy. Thank you for listening to me.